Hello, in this video we are going to learn about SN1 reaction mechanism. SN1. What is mean by SN1? Here 1 indicates uni, means 1 unimolecular nucleophilic substitution reaction. So here S stands for substitution, N stands for nucleophilic, and 1 stands for unimolecular. So the entire word is unimolecular nucleophilic substitution reaction. Means one of the nucleophile is going to substitute with another nucleophile. So before going to that, first let us understand what is nucleophile. A nucleophile is an electron pair donor to the electrophile by just forming a covalent bond. So what is mean by nucleophile? Nucleophile, we are going to show like this. Nucleophile is an electron pair donor by donating electron pair to an electrophile by forming a covalent bond. This is the definition of actual nucleophile. Right. So here just take an example of a simple reaction, SN1 reaction. So how we are going to represent? So Rx, this halogen is having a 3 lone pair of electrons, which is a nucleophile. So this is going to be replaced with any nucleophile, means substitute. So this is going to outgoing and the nucleophile is going to be incoming. So alkyl halide is undergoing nucleophilic substitution reaction. So this is the simplest example for the unimolecular nucleophilic substitution reaction. So it is basically a two-step reaction. So two-step reaction. In the first step, this alkyl group, halogen group is going to be leave, so that we are going to get a reaction intermediate which is called carbocation intermediate we are going to get. So this is the slowest step, which is also rate determining step. After that the nucleophile is going to attack. So now nucleophilic substitution takes place, right? So this is the fast step. So this is a two-step reaction, and the first step is formation of carbocation, and that will be the intermediate, right? So here the solvent plays a major role. And what is the solvent we are going to use in this case? The solvent is polar protic solvent. Examples of these polar protic solvents are water or alcohol or any acid are the polar protic solvent. Since it is forming a carbocation intermediate, so the carbocation intermediate will be the most stable one, will be the most fastest reaction. So this carbocation stability order will be 3 degree carbocation is more stable, then 2 degree, then 1 degree. Example, if you take, suppose if the carbon is positive charge, so in presence of plus I groups the stability increases. So the more the stable carbocation, the fastest of the reaction. So in case of 3 degree carbocation, the reaction takes place fast. So this is the order of rate of SN1 reaction. And since it is forming a carbocation intermediate, so if the carbon is a chiral center, if the molecule is having if a molecule is having a chiral center. What is mean by chiral center? Suppose if you take this carbon, here chlorine, here methyl, here ethyl C2H5, and this is pH. If a carbon is attached to 4 different group of atoms, suppose in this case if you take here chlorine and here methyl, here ethyl, and this is phenyl group, so this carbon is called a chiral carbon, right? Suppose if it is going to nucleophilic substitution, first Cl minus RDS, rate determining step, Cl minus going to be eliminated. So here the formation of carbocation, and this carbocation will be a trigonal planar in shape. So here CH3, here pH, and here C2H5. So in between the vacant orbital. Since it is having a trigonal planar carbocation intermediate. So to the nucleophilic substitution can be done from the above the plane or the below the plane. So you will get to two different types of products. One is retention product, other one is inversion product. Retention means on the same side if the nucleophile is coming, that is called retention. Suppose here in this case on the same side where the chlorine is there, so that nucleophile is going to come, right? So here this one CH3, here C2H5, and here pH. This is same side, so retention product, retention, and 50% inversion means on the opposite side nucleophile is substituted, CH3, here C2H5, and this pH. So equimolar means equivalent amount, equimolar mixture of retention and inversion products are called racemic mixture. So you will get a question that why racemic mixture is possible in case of SN1, because of the formation of trigonal carbocation intermediate. So there is possibility of incoming nucleophile to attack above the plane and below the plane. So this will be the racemic mixture. And now about the leaving group ability. So the leaving order, suppose if you take this one, the the alkyl halide, in case of alkyl halide, suppose this X is equals to iodine, bromine, and chlorine. So out of these three, Ri is good leaving group because of the size and the difference in electronegativity is less. So Ri is going to leave, iodine is going to leave very easily. So Ri, alkyl group order of leaving, so Ri is fastest, iodine is leaving fastest, then bromine, then Cl. So this will be the SN1 mechanism. Thank you.